So when we are working on rational expressions, you are talking about expression that looks like a rational number, like 2/3. This is a rational number. It could be something that looks like a 5. It could be something that comes in decimal value. These are things that we call rational number. That's what we did back in term 1 or term 2 earlier this year. We call them rational number. Now we are going to look at rational expressions. Expressions as in anything that will involve the use of more than just number. So it could be something like things that we've seen in the past, such as, well, we did something like this earlier in grade 10, like 2x plus 3, we get a straight line. Or it could be a trinomial that looks something like this. What we are going to do is to work with a combination of these things together, turning them into a fraction of two polynomial. Rational number, we have a fraction of two numbers. Rational expressions, we will have a polynomial divided by another polynomial. And what we will do today is to give you a very in-depth review of how to deal with trinomial like this, or difference of squares, or anything that can be factorized. And then once you understand, once you remember how, once you recall everything you've learned before, you will be ready to learn rational expressions. When we bring them all together, when we add different rational expressions together, when we multiply, when we divide different expressions, you will then be able to simplify all these questions here. So here, before we start lesson number 1, we are going to spend one class on factorizing quadratics, or technically we call it trinomial. But there are some trinomials that are not quite quadratics. So it could be something else as well. How do we factor all these polynomials here? So here in example number 1, when you take a look at this trinomial, x squared minus 4xy plus 3y squared, we've seen this kind of questions before, probably without the y. You know how to factor a trinomial like x squared minus 4x plus 3. You will try to turn it into a product of two brackets. And you will try to come up with two terms that will give us a product of x squared. And then to complete it, we will try to come up with two numbers that will multiply to give us positive 3 and add up to the middle term. So technically, minus 1 minus 3. But what happened is, yep, we have a y here. Instead of just -1 and -3, we want two numbers or two terms that will multiply to give us positive 3y squared. -1 times -3 will give us positive 3, but we have the y squared at the end. I want -1y and -3y at the end. The product of these two terms will now give us positive 3y squared And when you double check, the inside and the outside do give us negative 4xy in the middle. For the inside, negative 1y times x will give us negative 1xy. And for the outside, x times negative 3xy, they do give us negative 3xy. So combining these two terms together, the inside and the outside together will give us negative 4xy. So this is how we factor a trinomial that comes with more than just x squared and x. If it comes with a y squared at the end, make sure you factorize your trinomial in a similar way. Using the same concept, we can now factor this trinomial. This trinomial started with 3a squared. We want two terms at the front of these two brackets to give us a product of 3a squared. And similar to the previous question, I'm going to split the a square into two pieces. I'm not going to put one of the a square at the front and then the next one would just be a number. It isn't just 3 times a square or 1 times 3a square. I want to even it out. So in this case, what would go here and there? 3a and a, yes. 3a times a will give us 3a squared. So that's the first of your FOIL. We are not too sure about the outside and the inside, but when it comes to the last of your FOIL, these two numbers or these two terms multiplied together should give us negative 6b squared. What are the possible choices? 2 and 3, 1 and 6, or in this case, it will be 2b, 3b, or 1b, 6b. Now, knowing that we may have 2b, 3b, or 1b, 6b, there are a number of combinations that I will eliminate right away. I will not use 3b and 2b. The reason why I won't use this combination is because I don't see any GCF from the question. So there is no way I will end up with something that carry a GCF. If the trinomial at the beginning doesn't come with any GCF, the result shouldn't have any GCF. So for sure, it wouldn't be 3b and 2b. It could be 2b and 3b. We don't know, but we need to try it out using the inside and the outside. The outside will give us 9ab. The inside will give us 2ab. And in order to get the middle term, plus 7ab, I want this to be a plus and this one to be a minus. To double check, if I have a minus here, if I have a plus here, yes, we do end up with negative 6b squared as you multiply those two together. So in this case, this is how I factor this trinomial. Some of you may have a different method factoring your trinomial. Some of you may prefer bringing the 3 to the back. bring your 3 to the back and try to factor your expression this way, which I don't see any problem at all. You can definitely factor your trinomial in this way. We call this method decomposition. You decompose this middle term into 2 pieces so that you can factor this by grouping. You can use this method, but as you can see, it takes a relatively long time to factor this trinomial. Oops, I should have A here. So once again, you are still going to end up with the same result, but compared to what we've done here, it takes a lot more steps to factor your trinomial.